Okay, guys, we're going to go over we're going to go over another type of question that you might see on your quiz and your test. The ones that we've been going over have just been plain probability with marbles and spinners. Okay, that was the week before spring break. This week we've been going over and or statements. Okay. These right here are conditional probability, and these are going to be statements that have the word given in them. Okay. So what we're going to do, okay, so the first problem says a math teacher gave her students 2 tests. 25% of the class passed both tests, and 42% of the class passed the first test. What percent of those who passed the first test also passed the second test? Okay. Another way to reword this is what percent of those who passed the first test given that they also passed the second test? So you will see the word given. I'll write it in here as well. Okay, so you'll be able to put here, you can say given that they also passed the second test. Okay, so you will see given. Every time you see the word given, you're going to use the formulas that we're going to use here. Okay, so to figure this out, okay, your question is going to look like this. Okay, so this straight line here represents the word given. Okay, so a way to read this right here is what is the probability that they pass the second given that they passed the first test? Okay. All right. So your formula is always going to be and on top and what you're looking for, which is the second on the bottom. Okay. So the probability that they pass the second test given that they already passed the first test. Okay. So first and second is going to go on the top. So all of your and statements are in your numerator. Okay. And then what you're actually trying to find, okay, which is right here, what percent of those who passed the first test is going to be on the bottom. So what you're looking for is on the bottom. Okay. And then your and is on the top. Okay. So the probability of first and second. Now, I'm given percentages, and I want them in probabilities. So this 25% is really 0.25, and that 0.25 is for both tests. Okay, it says it right here, both tests. Okay, this 42% is really 0.42, and that's how many passed the first. Okay, so you're looking at, okay, how many. It says what percent of those people who passed the first test also passed the second. So you have both that passed 25% that passed both, 42% passed the first. We want to know what percent passed the first that also passed the second. Okay. So first and second is 0.25. So that's my and. And then who just passed the first is here. Okay, so you're going to divide those probabilities. So 0.25 divided by 0.42 is 0.60, okay, and that's equal to 60%. Now, you might see different versions on your quiz. I might just ask for this. I might ask for probability, or I might ask for percent, okay? I don't know. Okay, so there's going to be asking you different variations. So every time I ask you, it could give it to you as a ratio or as a fraction. I could ask for probability, you'll give me the decimal. If I ask for percent, you move the decimal or multiply by 100. Okay, let's go over example 1. Okay, so it says a jar contains black and white marbles. 2 marbles are chosen without replacement. The probability of selecting a black marble and then a white marble is 0.34, and the probability of selecting a black marble on the first draw is 0.47. What is the probability of selecting a white marble on the second, given that the first marble drawn was black? Okay, so keyword here is given. That tells me that I'm going to do and divided by something, okay, whatever I'm looking for. All right, so let's go ahead and highlight some important things. So the probability of selecting a black and then a white marble, so black and white is 0.34. Okay, so that's important because that has and. And the probability of selecting a black marble on the first draw is 0.47, so that's also important. So black marble on the first is 0.47. Okay, so the question says, what is the probability of selecting a white marble on the second, given that the first marble drawn was black? Okay, so the two things that you're given are and black, so you're going to do your and probability, which is 0.34, divided by 0.47 here. When you put that in your calculator, you get 0.72, and I'm asking you for probability, so this should be your answer, okay, because it says what is the probability. Here I was asking you for percent, so I needed percent. Here probability, I need probability, so you would not give me 72%. If I said what is the percent, then you would switch it. All right, example 3. The probability that it is Friday and that a student is absent is 0.03. Since there are 5 school days in a week, the probability that it is Friday is 0.2. What is the probability that a student is absent given that today is Friday? Okay, so keyword here is given. All right, so I know I'm going to use this probability, my and probability divided by something probability, okay? So some important things here are Friday and absent is 0.03. All right, another thing that is important is out of the days of the week, that today is Friday is 0.2. All right, what is the probability? So I'm asking for probability. So no percentage. Okay, so my and statement goes on top. So I'm going to take my and statement from here, put my 0.03 on the top, divide it by 0.2, 0.15. That's what I'm asking you for. Do not want percent because I'm asking you for probability. All right. I'm going to go to the example, so I'm going to go to page 2. I'm going to skip the third one since it's already done for you. Okay, so number 1, Tanya is selling 2 kinds of cookies, chocolate chip and sugar. After going to 100 houses, she determines that 41% of people bought chocolate chip cookies and 38% bought chocolate chip and sugar cookies. What percent of people bought sugar cookies given that they already purchased chocolate chip cookies? Okay, so keyword here is given. Okay, let's do it in yellow to keep it consistent. Okay, so keyword here is given. So I know I'm going to do my and. I'm going to do my probability of chocolate chip and, let's do this over. So I'm going to say I need the probability of chocolate chip and sugar divided by the probability that there are chocolate chip. Okay, because that's what I'm asking for. What is the percent of people who bought sugar cookies given that they already purchased chocolate chip? Okay, so we need to highlight some important things in our problem. So after going to 100, she determines that 41% of people bought bought chocolate chip cookies, and 38% bought chocolate chip and sugar cookies. Okay, so my and, remember, goes on the top. All right, so 0.38. Remember, change these percentages to probabilities. So 0.38 goes on the top because that is your and statement. and 0.41 is your denominator. So 0.38 divided by 0.41 gives you 0.9. Okay, now I said what percent of people. I did not ask for what is the probability, okay? So I asked you what percent of people bought sugar cookies, okay? Now, I'm asking you for percent, so you're going to take this probability and you're going to multiply 100 to give you 90%. So this is what I'm asking you for. If I was asking you for probability, you would give me this answer. Okay? All right, let's go do example number 2. The Braves have a doubleheader on Saturday. The probability that they win both games is 0.31. So that is important. So I'm going to go ahead and highlight that. Or sorry, 31%. The probability that they win both games, 31%. The probability that they win just the first game is 71%. Okay, what is the probability that they will win the second game given they won the first? So keyword here is given. So I'm going to do my and statement. Okay, so I'm going to say probability that they win, what was this? What is the probability that they win the second given that they already won the first? Okay, so that, remember that straight line means given. So this formula is probability of second and first divided by probability of first, because that's what I'm asking you for in my problem. Okay, so probability of second and first. Okay, we already have that, which is 0.31, because if I win both games, that's the first and the second game. Probability of just the first game is 0.71. So 0.31 divided by 0.71 is 0.4. Okay, now it says I'm asking you for probability, so I'm going to leave this as my answer. Okay, 0.4. Okay, we'll go over one more. During a storm, the probability of the power in the cable going out is 31%. So my and that is important. So power and cable going out is 0.31 or 31%. All right. The probability that just the cable will go out is 54%. And then what is the probability that the power will go out given that the cable is already out? Okay. So I know that this is a given statement, so it's going to be probability the power will go out given that the cable is out. Oops. Okay. Now, this formula is probability of power and cable divided by probability of cable. Okay, now if you notice, this right here, this formula is exactly what I said in my question. Okay, all right, let's go ahead and fill this out based on our percentages. Okay, so probability of power and cable. So power and cable was 0.31 divided by just the cable going out is 0.54. So remember, percentage, this is not a probability. This is a percent. Okay, this is not a probability. That is a percent. So you need to make sure your probabilities are between 0 and 1. Okay, so 0.31 divided by 0.54 is 0.6. Now, I asked you for probability, so I'm going to leave my answer as 0.6. If I asked you for percentage, then you would say this times 100 is 60%. Okay?